Lesson 3-4. We're going to do all of 3-4 today. We're going to do properties of logs. So there are 3 parts, A, B, C. And the good news is there's only 3 properties of logs. That's not too bad. Yeah. So here we go. First part. Let's go over our props. Now it says here that let B, R, and S be positive, and B is not 1, and C is any real number. So they're just like normal numbers, okay? So if you take the log base B of the product of 2 things, R times S, there is a property, a log property, that tells us that we can split that up into 2 logs with an addition in the middle. Log base B of R plus log base B of S. And the reason for that, because you're kind of like, how does multiplication turn into addition? Well, if you had something like x squared times x to the 3rd, what do you do to those exponents? You add them. And what's a log? It's an exponent, so you add them. Okay? I do have a proof if you'd like to see it. No?
Actually, sure.
Yeah? Do you like proofs?
No, I just like reading them.
Oh, yeah.
I don't like doing them, I like reading them.
Right? You like following them and like figuring them out? Yeah. Proofs are hard. I took a whole class called Strategies of Proof. All right, now the next one's log base B of R divided by S. And so,
Can I guess?
yeah, guess.
Is it minus?
It is. All right, so log base B of R minus log base B of S. You did these last year. Do you remember them? Nope. Did a whole chapter of logs last year. Okay, and then finally the last one, and this one is my favorite. Yep, I have favorites. Log base B of R to the C, and maybe some of you have already been using this one. This one is you bring that C down to the front, and it becomes multiplication. And think about it. When you do something like x squared to the 5th, what do you do to the exponents? You multiply them. This is just raised to the power, so they're exponents in themselves, and you bring that C down. All right, those are your 3. Memorize them. Know them. Know how to use them. All right, so that was part A. Part B, we are now going to use our properties to, we're going to go both ways. We're going to expand, and then we're going to condense. The expanding is going to be important to know, especially when you're in calculus next year. Do you plan on taking calculus? AP Calc is even like a huge step from this class, just so you know. So something to look forward to. All right, here we go. Number 1. Let's go ahead and expand and simplify if possible. So we're going to take these logs and we're going to write them in as many logs as we can and simplify them as much as we can too. So here we go. Let's do log base 2 of 8 times x times y to the 4th. Now I like to tell you the mistakes that people make so that hopefully you won't. A lot of times people will think that the 8x is one thing and y to the 4th is one thing. But that's not true. There are 3 different things here. Okay? So we're going to expand this into 3 logs. So always think of the number as its own thing, the x as its own thing, and the y to the 4th as its own. Okay? So here we go. We get log base 2 of 8 plus log base 2 of x plus log base 2 of y to the 4th. Now, we're not done. We now need to simplify a little bit more. Okay, the 4 is going to go to the front. There's also one other thing to simplify. Yeah, log base 2 of 8. Okay, if someone came up to me like 3 years ago and said, hey, how old's Jack? Oh, he's log base 2 of 8. No, I wouldn't say that. I'd say he's 3, right? So that's 3 plus log base 2 of x plus 4 log base 2 of y. So if that was a log base 2 of 7, you would just leave it. But since it can be simplified into a nice, nice number, then you do that. All right. Do you remember doing those last year? No. Okay, great. Let's try this one. This one's a little strange. Log base 5 of 50. And you probably sit there and go, 5 to the what is 50? I can't figure that out. It's actually not a nice number. But what they want you to do is they want you to break this down and simplify it. And so what I can do is I can rewrite this as log base 5 of 25 times 2. Why did I pick 25? Well, because 5 squared is 25. Okay? And then we can rewrite this as, using our properties, log base 5 of 25 plus log base 5 of 2. And then I can simplify this first part. This is just 2. 5 squared is 25. Plus log base 5 of 2, which is not going to be a nice number. And that's how simplified they want this to be. It's kind of yuck. You didn't do that last year. We didn't do that kind of thing. Okay, part C. These log properties also work with natural log. So let's do the natural log of the square root of x squared plus 5 over x. All right, so we're going to expand this into two logs this time. So let's take the top, the natural log of the square root of x squared plus 5, and then subtract natural log of x. And now they want you to simplify the square root. If you have a square root, it's to the 1/2. If you have a cube root, it's to the 1/3. So that would be an exponent of 1/2. We would bring that down to the front and write 1/2 natural log of x squared plus 5 minus the natural log of x. And that would be your answer. You cannot simplify this at all. Some people think, oh, I can distribute that. No, this is the natural log of x squared plus 5 has to stay together. And that would be your final answer. Okay, let's do one more. The last one's a tough one. You ready for it? Yep.
Yeah.
All right, let's do log base 6 of 1 divided by 72 m to the 4th. Okay. Now there are 3 different things here. I have a 1 up top, a 72, and an m to the 4th. So I need to write this in 3 logs to start off with, okay? So we're going to write log base 6 of 1 minus log base 6 of 72. And then here's your option. You can write minus, or you can put parentheses and put a plus. So it's really up to you. If they're both dividing, I'm just going to write minus log base 6 of m to the 4th. Is everyone okay with that? They're both minus because they're both in the denominator. Okay.
What are you talking about with that addition?
Yeah, you could have instead have gone like that and put an addition because the whole thing is on the bottom, but these are multiplied together. But I kind of like just leaving it as minus. Yeah. So now I get to do. Ooh, that was good. Okay, sorry. Minus. Aw, wrong color. Now we've got to simplify. What is log base 6 of 1? 0. Good. And then this, 72. Is that bothering you at all? It's kind of a big number. Like, why 72? Well, they gave you 72 because it's 36 times 2. Yeah. You got to look for those. They're weird. And then minus, we'll bring that 4 down. Okay. I don't know. Does that bother you?
Yes. No. Put it to one line.
Okay. So now we get log base 6 of 36 plus log base 6 of 2. They should. Thank you. That's a minus, and that's a minus. Who said that? That was really good.
I said
Nope.
it.
Why won't that? Okay. There we go. All right, and then we have minus 4 log base 6 of m. Yes, 0 minus. So they're both minus. You're right. Now, what is log base 6 of 36?
2.
Okay, so yeah, we have a negative 2, but it is 2. And then minus, and just leave this one. Log base 6 of 2 minus 4 log base 6 of m. And I think that's it. Is that it? Yeah. That's as far as you can go. Pretty bad, huh? Yep. Why do we do that? I don't know. It's fun. For fun. Yep, my kind of fun. All right, now let's go on to the next one. Number 2. We're only on problem 2. We're going to simplify write as a single log. Okay, we're going to write as one single log. So the whole thing's going to be all expanded out, and we got to get it all back to one log. So we'll start with an easy one, and then we'll work our way to impossible or difficult. All right, here we go. Let's do the natural log of x to the 5th minus 2 natural log of xy. You don't like my cursive L? I like it. Especially for natural log, huh? Me too. I usually don't for log, but I do for natural log because it looks like a 1. I don't know. That just doesn't look good to me. I always go like that. Oh, whatever. Okay, so here we go. We're going to simplify into one single log, so write your one single log. A lot of times when there's a minus, people write a log up top and a log on the bottom. You don't want to do that. It's one single log. And then up top we have x to the 5th. And in the denominator, this 2 is going to move to here and square both of these terms. See, it's xy squared. So let's write x squared, y squared.
Oh, so you're just doing it reverse.
Yeah. Yep, got to go both ways. Okay, did I lose anybody on that step? Are we okay? And now we have one last thing to do. You need to know your exponent properties that you learned back in Algebra 1. You have an x to the 5th over x squared becomes x cubed, and then we have y squared. Okay, B. We're getting there. Log of 5 minus log of 3 plus 1/2 log of x. Now, for this one, I'm going to get some of you on this one. I did last year. I'll do it again this year. We're going to write as one.
Do it again.
Yeah. We're going to write this as one single log, okay? But you need to be careful. Now, this one doesn't look too difficult, right? So it's log of 5 minus log of 3. So that would be 5 over 3. And here's where I'm going to get you. Plus 1/2 log x. So that's going to become the square root of x. But a lot of people are going to put it in the denominator. It doesn't go in the denominator, okay? It's plus. When I tell you to multiply a fraction times x, are you going to put that in the bottom of the fraction? No. That goes up top. That's where it would go, okay? But a lot of people, they'll see the minus. They'll go down here. They'll see, oh, plus, so that means it's times that one. It's not times that one, unless I had parentheses around it, right? Do you see the difference? If I had parentheses around this, then that would be log of 5 over 3 times rad x. Without parentheses, it's getting real messy, it looks like this.
Wait, why did they go into radical?
Oh, the 1/2. The 1/2 is the exponent on x, so x to the 1/2 is the square root of x. Yep. Okay, letter C. How many more do I have of these? Two more. Letter C. This one's tricky. 1 minus 1/3 log base 2 of x. Now we're supposed to write that entire expression in one log, including the 1. Okay? So I need a log base 2. How do I write 1 as log base 2?
Log base is 2.
Yes. Log base 2 of 2 is 1. We're going backwards. It's weird, huh? We've never changed 1 to be log base 2 of 2. We've never done that. But it is. It's true. And now we're going to take those and write them as 1 log base 2. So we have log base 2. You have a 2 up top. And what goes in the bottom? Cube root, yeah, the cube root of x. You do not need to rationalize any of these. Don't worry, you're fine. Okay, this 1/3 right here becomes the exponent on x, and x to the 1/3 is the cube root of x. Okay, the really tricky part about this is trying to change a constant or a number into a log. It's kind of weird. Okay, last one. Here we go. Let's say we have 2 times the natural log of x to the 5th minus 1/8 natural log of y minus 3 natural log of z. You want to try this one?
Sure.
I have a sure and a nope. Anyone in between? I'm just going to wait. No?
I mean, yes.
All right, let's do it. Multiply by 2, everything by 2. So I have 2 natural log of x to the 5th minus 2 times 1/8 is 1/4 natural log of y minus 6 natural log of z. Okay, maybe that helps a lot. And then we're going to write all of this in one single natural log. So this 2 moves up to the top. And when I have 5 to the 2nd power, what does that become? X to the 10th. Good job. And then minus y to the 1/4, which would be on the bottom, 4th root of y. Then minus, that's going to go on the bottom too, z to the 6th. Anyone get that? No, not one person. Okay. Oh, you weren't done. Okay, you would have gotten it.
Maybe.
Maybe. All right. You know, those are tough. There's a lot going on there. Yeah.
But negative 6 natural log of z is a negative. Wouldn't it be the negative 6?
You have to think of this as a minus, really, instead. So the 6 moves to here, and it's minus, and minus means division for logs. Yep.
You guys ever just listen to the say? Just funny.
What?
No, I don't know. It's like, was it rad 4 z to the 6th?
Oh.
Yeah. Oh, yes. It was.
That's so funny. Yeah. Oh, I'm sorry. All right, change of base formula. Some people need it, some people don't. Okay? If I wanted to find out what the log base 3 of 16 is, some of you have a calculator that will do that.
See, you guys are here.
Some of you don't. So here is log base b of x. Change of base formula is you're going to take the log of x, divide it by the log of b. Okay? So for example, what am I on? 3. Only 3 examples today. Actually, there's 4. We're going to take and we're going to find out what log base 3 of 16 is approximately equal to. We're going to round to 4 decimal places. So there's 2 ways to do that. One is, if you have an older calculator, everyone's calculator has log base 10. So you would do log of 16, close the parentheses, divided by log of 3. Okay? And you get approximately 2.5237. Now, if you have a newer calculator, it will take the log of any base. You don't need the change of base formula. And the way that you find it, there's 2 ways. If you hit alpha window, that's going to give you a little shortcut to number 5, the log. So you can put a 3 in, a 16. And your calculator will tell you it's the same answer. Okay? Yeah. If you forget the shortcut where it's at, you would go to Math, and you just scroll down to A, log base. Okay? Even if you have an older calculator, you can still do it. I don't know how, though. You have to do commas and stuff, but I don't know how. Yeah. So there you go. So for number 4, and this works for any base. If you want to change it to base 2, you can change it to base 2 as long as you do log base 2 of x divided by log base 2 of b. So they might ask you to take something like this, log base x of 5, and rewrite this in natural log. Okay, so you're just going to use your change of base formula that I just gave you. So you would write natural log of 5 divided by the natural log of x, as long as x is greater than 0. Okay? All right, that's it.